Hello students, welcome to fifth and last session of Ansys Fluent Learn from Home. Uh, I think you might have enjoyed the previous sessions. So in this session we are going to model and simulate the 3D heat transfer problem. So we will start with our session. Hello students. So in this session we are going to take the problems of 3D analysis problems of heat transfer. So we'll take the simple classical case of heat exchanger. Okay, parallel for either counterflow heat exchanger. So we'll go to fluent. Okay, we will go to geometry, right click, new design modular. We had to wait for some couple of seconds for window to open. Okay, so first of all we'll change our unit to centimeter. Then we'll select XY plane. Then we'll select XY plane and click on the new sketch. Okay, after that we will make the weaving plane normal to it and we will go to sketching. Okay, in the sketching basically we want to model two pipes. So select the circle. We will select the origin as center and we will draw our first circle. Again we will take another circle. We will take the same origin. Okay, and we will draw second circle. After that we will go to dimension. First of all we will check whether they are coinciding or not. So we'll select this concentric and then we will select circle 1 and 2. So even if they are not concentric, so they will become concentric. Okay, after that we will go to dimension. We will specify the diameter of inner circle, let it be 2.5 centimeters. The diameter of outer circle be 5 centimeter. Okay, after that we will go to create, extrude. Okay, after that we will apply the sketch 1. Let it be frozen. Okay, because we are supposed to make another pipe, so in that case we will apply the material condition. We will change it to both sides symmetric and length, uh, total length of the pipe be 50 centimeters, so 25 centimeter on both sides. After that we will generate it. So you can see a hollow pipe is generated. Okay, of length 50 centimeter. After that again we will select the plane XY and we will draw another sketch to it. Okay, we will go to sketching. In sketching we will select our circle. So from the same origin, okay, we will draw one circle. After that we will go to dimension. We can specify its diameter as 2.5 centimeter. Okay, which is almost equal to inner diameter of outer pipe. Okay, after that we can go to create, extrude. Okay, we will apply sketch 2. Okay, here we will keep add material and here we will change this to both sides symmetric and same length 25 centimeter. So we will generate it. Okay, so you can see hollow pipe has been a filled pipe has been generated. Okay, so this is our outer pipe. We can rename it as outer pipe and this is our inner pipe. So we can rename it to inner pipe. Okay, so in this way we had done the modeling part, so we can close the design model. Then we will go to meshing. We had to wait a couple of seconds till the meshing window open. Okay, so basically our model will be attached to this meshing, so it will take some few seconds. Okay, so our model is attached. First of all, we will see what is the we can go to the quality. We can change the smoothing to high, and we can go to sizing. We can change the element size. By default it is 2.5 centimeter. We will change it to 0.01, that means 1 centimeter, and then we will see what is the quality of mesh we are getting. Okay, although no, so the quality of mesh is not that much good. Okay, so we will simply do one thing. We will go to mesh, right click, insert, method. We will change the method. Okay, we will apply to both body 1 and body 2, inner pipe and outer pipe. So apply it, then change the method to tetrahedron. Okay, and now we will generate the mesh, and now we will see the quality of mesh. So the mesh is being generated. Okay, now you can see it is a very good quality mesh now. Okay, almost it is symmetric about all the sides. So we can say this is a symmetric mesh. Now one thing I want you to notice here, the connection is there between two surfaces. Okay, so if you click here, okay, so you can see, okay, you can see here, where is the connection? The connection is between the outer surface of inner pipe and inner surface of outer pipe. Okay, so just remember here that the connection is there between two surfaces. Now what is the use of it, we will going to see later on. Okay, okay, after that now we will define the boundary condition. So let sorry, first of all click this surface. Okay, you are supposed to click the surface or face, then click on this surface, and you can create a name. You can call it as inlet hot. Okay, so it will be the inlet of hot fluid, and this will be outlet of cold fluid. So outlet cold. Basically we are doing for counter flow arrangement. If you want to do for parallel arrangement, you can give the both inlet on same side. After that name selection, here it will be outlet for hot fluid. Okay, and this will be inlet for cold fluid. Okay, so in this way you can give the name selections. Okay, so you can cross check here. This is inlet hot, this is outlet hot on other side, this is outlet cold, and this is inlet cold on this side. Okay, so we had done with the meshing part, so we will close the meshing. After that, next step is to update the mesh. We had to wait till a green tick appears on the mesh. Okay, so after that we will go to setup, and we will open the Fluent window. So click on the double precision and wait for window to get open. So our Fluent window is being opening. First of all, whatever the mesh we had attached, we had generated, that mesh will be attached to the problem. So it will hardly take some fraction of a second. So we have to wait 5 to 10 seconds. Okay, so you can see the mesh has been attached now. After that, we will go to model. Okay, where heat transfer is going to take place in our case, so we will apply the energy equation. Then we will go to viscous flow, and we will change it to K epsilon turbulent model. Press OK. Okay, rest of the models are not associated with our problem. Okay, after that, in material library, water is not there. recall the water from Fluent library. We will go to Fluent database. Then we will go to water liquid and copy it. Okay. After it is being copied, we will go to cell zone condition. In cell zone condition, you can see this is the inner pipe and outer pipe. By default, they are fluid. Okay, but that default fluid is air, not water. So we have to click on the edit, and we will change it from air to water liquid. And press OK. Similarly, for outer pipe, we will change the fluid from air to water liquid. Okay, and we will click OK. Okay, after that, boundary conditions. Okay, so see, this is the contact region which I had shown you. After that, we will go to inlet cold. So basically, inlet cold is velocity inlet. Now, for better heat transfer, we will keep this value of velocity smaller. Okay, and for inlet cold, the temperature is 300 Kelvin. Set OK. Similarly, for inlet hot, we will click on the edit. Here we will keep the same velocity 0.01 meter per second. Lower value of velocity and temperature we will set to 400 Kelvin. Okay, and outlet, you can see outlet are pressure outlets, so we will keep them pressure outlet as it is. Okay, after that, see, this is the most important step, mesh interface between the contact region which I had shown you. Okay, these two contact regions, inner surface of outer pipe and outer surface of inner pipe. So you had to select this and you had to couple them. Why couple wall is required? Because here heat transfer is going to take place. So if you forget this step, okay, of coupling them, so in that case no heat transfer will take place. So remember, this is a very important step for solving the heat transfer problem. Okay, and you're supposed to do them whenever two surfaces are meeting with each other. Okay. After that, so our problem model is set, so we will initialize the solution. Okay, we will select standard solution, initialize it from all zone, and then initialize it. It will take some couple of seconds. Okay, after that, we want to also see the animations. We will go to solution animation. We will go to contour. Okay, we will deselect all this and we will insert our plane, viewing plane. So its name will be plane 15. Okay, first of all, it should be normal to okay, let it be z plane. Okay. After that, see, you can see here the x coordinate of the plane should be 0. It should be along y and z axis. So we will put all the x coordinate 0. Okay, also put this 0 coordinate as 0. Okay, z0 is also 0. Then for y1, y2. Okay, along y direction, I think the diameter is 5 centimeters, so 0.05. You can 0.0 or you can put it to 0.110 centimeter. Okay, and for z, the length is 50 centimeters, so 0.5. Okay, create it. Okay, then from here we'll set temperature and okay, first of all we will see pressure. Okay, so pressure and plane 15 7 display. Okay, so after that we will go to here, we will name it as pressure animation, then select the contour and we want it for it will be right view. Okay, set it okay. Okay, then again we will go to solution animation. We will have this contour, deselect this. We will have a second animation for velocity, again on the same plane 15. Okay, select this, give the name velocity. isometric view we will change to, let's say, right view. Okay, then again solution animation. For temperature, again we will go to contour, we will select the temperature, deselect all, select plane 15, save and display. Okay, and after that select the contour, you can give the name temperature and view will be right view. Okay. So our animations are set, so we'll go to run calculation, and let's say we will have 250 iteration. So calculation have been started. See, I will stop the video, pause the video, because all this calculation will take a lot of time. So in order to optimize the video, I will pause the video. You can say this is a temperature profile. Okay, hot water is coming in and it is being cooled, and this is a cold water which is coming in and its temperature is increasing. Okay, this is a velocity profile, pressure profile. Okay. Okay, so our calculations are completed. 250 iterations are over. You can see all these curves have reached to the value of e to the power minus 6. Okay, you can see here e to the power minus 6, e to the power minus 7, and the curve has become flat. Okay, that means it is, although the solution is not converged, but if we do for further calculation, it will become a horizontal line. Okay, so we almost got a converged solution, you can say. Okay, so we will close these tabs because we will see the animations. Okay, so we will go to animation, solution animation playback. So first of all, for pressure. Okay, so we will play the video, so you can see the pressure is basically decreasing in the direction of flow for a hot fluid, and also the pressure is decreasing. Okay, this is the inlet of cold fluid, so the pressure is decreasing in the direction of cold fluid. So pressure drop takes place whenever the fluid flow is taking place. Okay, after that, velocity profile. Okay, so this is a video of velocity profile. You can see near the center the velocity is maximum and that velocity is reducing in normal direction, and this blue line indicates the boundaries. Okay, so no slip condition exists on the boundaries. Okay, after that we will see the temperature. Okay, so now you can see the temperature. This is an inlet of hot fluid, so it is being cooled from red to yellow zone. Okay, you can see that it is being cooled, and this is the cold fluid which is at a 300 degree Kelvin, and it is being heated in the direction of flow, and more heating is taking place near the pipe surface region. You can see here. Okay, so we'll stop the uh, animation and we will go to CFD post. We have to wait for some 5 to 10 seconds. Okay, after that we will right click the result and we will click the edit. Okay, again it will take some time for a window of CFD post to open. Okay, so our CFD post is open now. So first of all we will insert the plane. Okay, so our plane should be along YZ direction. Okay, from here we will change it to YZ direction and apply. So this is our plane. Okay, you can untake this plane one, then we will go to contour. Okay, select OK, then select this plane one. On this plane one, first of all we will see the pressure profile, make number of contours to 100. Okay, so you can see here this is a pressure variation which is taking place in the direction of flow. The pressure is decreasing in the direction of flow. After that, for velocity, select the velocity. Okay, so you can see the velocity here. The diameter of the pipe was uh, 2.5 centimeter. Okay, so here at the center the velocity is maximum, and here although it is a hollow pipe, but flow passage is only for 2.5 divided by 2, so 1.5 uh, 1.25 centimeter. Okay, so here at the center the velocity will be less as compared to here velocity, but you can see again the velocity is increasing towards the center, and on the pipe wall you can see the velocity is 0 because of no slip condition. Okay, after that we will see the temperature profile. Okay, now you can see the hot fluid at 400 Kelvin. Okay, here it is not showing in Kelvin, so we will quickly change the legend. We'll go to legend, then appearance we will change here to fix. Okay, now you can see it is in Kelvin now. Again we will come back to contour 1. So you can see at the inlet 400 Kelvin. So from 400 Kelvin it is reducing. In this yellow region it has become 372. Okay, and in the green region it has dropped down to 350. Similarly, from the inlet of the cold fluid, the temperature was 299 or 300 Kelvin, and it has reached up to I think 320 Kelvin at the outlet. Okay, so how the flow is taking place, if you want to see, so you can go to streamlines. Okay, and you can have this surface streamline. Start from, okay, surface select as plane 1. You can have it 50 or make it as 100. Okay, we will see the animation. Okay, so you can see how the cross flow is taking place. Okay, if you want to have a 3D view, so you can apply on 3D. Start from inlet. Let's put inlet. Okay, and we will see the animation. Okay, so that is a animation of cold side. Similarly, if you want for hot side, you can select here hot, inlet hot, apply, and then you can view the animation of hot fluid. Okay, after that, okay, so I think we had almost covered. Okay, if you want to plot the graph of hot fluid or cold fluid, so you can insert the line from location line. Insert one line. You can suppose we are plotting for hot fluid. Okay, how the pressure is decreasing for hot fluid. So let it be. So coordinate will be along z. Okay, so minus 0.25 to plus 0.25. So for z it will be minus 0.25 centimeter to plus 0.25 centimeter, and make x and y coordinate 0. Okay, you can untick this stream. So you can see this is the line for our which is passing through the origin along z direction. Okay, and you can divide it into 100 samples. Okay, then we can go to chart. Okay, you can select here data series location line 1, along x-axis chart count, and along y-axis temperature. Okay, so you can see the temperature is increasing here. Okay, it is showing in reverse manner, so the temperature is decreasing from 400 to, at the outlet it is around 370, 367 or 368. Okay, again you want the exact temperature, you can go to calculator, function calculator. You can take here average of, let's say, outlet temperature of hot fluid. You can select from here temperature. Okay, calculate. So average temperature of hot fluid is 359 Kelvin. Similarly, for cold fluid outlet. Average temperature is 313 Kelvin or 314 Kelvin. Okay, in this way you can calculate the or analyze the terms, analyze the model. Okay, so hope you have liked the video. Okay, so in this way we had completed this problem. Now we will see another problem on PinFin, which is also a part of your academics. Okay, so second problem we will take for PinFin case, which is also a part of your academics. So we will go to Fluent and we will open new design modeler. We will wait for a couple of seconds. Okay, so first of all we will change the unit to centimeter. We will select the XY plane and plot a sketch on it. After that we will make the weaving plane normal and we will start our sketching. First of all we will create one rectangle. Okay, after that we will go to our dimensions, general, let this dimension be L1, this dimension be L2, this is H3, this is V4. So let it be 20 or let it be 10 or 20. This be 20, this be 10. Okay, sorry. Okay, so V4 and L2. L2 is 10. Okay. After that L1 is 10. H3 is 20. And L1 is 10. Okay, so we had created a square exactly having the center as origin. Okay, after that we will go to create, extrude. Okay, so basically this is our base plate. Okay, we will make it for that 2 mm thickness, let's say 5 mm thickness, and we will reverse its direction. Okay, and we will generate. This is a base plate. Okay, after that again on this XY plane we will draw one sketch and we will go to sketching. In sketching we will select a circle and we will go to dimension and let the diameter of this be 2 centimeter. Okay, after that we will go to create, extrude. Okay, and we will make its length as let's say 20 centimeter. Okay, then we will generate it. Okay, so now you can see both are were material, so they had combined to form a single body. Okay, see we are also supposed to make the fluid, so we will change it to add frozen, generate, and also this to add frozen. Generate. Okay, so both are add frozen now. Now we will create boolean and we will unite them. Select these two body and apply and generate. Okay, now it is a single PinFin, we can say, so we can rename it as PinFin. Okay, after that we will take this XY plane or YZ plane. Okay, on this YZ plane we will take one sketch. We'll go to sketching. In sketching we will select one rectangle. Okay, after that we will go to dimension. Let the distance of this height is L1, we'll say L1 as 10, this enter height as 20, and let this length be 30. Okay, so this is our sketch. Then again we will go to extrude, and here we will make both sides asymmetric. Okay, both sides asymmetric, and let on first side the length is 10 centimeter. Okay, we will make this as 10 centimeter and this is, let's say, 30 centimeter. Let it be 15. Okay, so 15 and 30. Okay, after that we will, in this case we will keep add material because this will be the fluid passage. Okay, now basically this pin fin is inserted inside this, so we had to separate them. So for that we will go to boolean. Okay, and in boolean we will subtract. Now which is the target body, this solid is a target body, and which is a tool body, this pin fin is a tool body. And do you want to preserve it? Yes. Okay, so we will generate this. Okay, so if we hide this solid body, so you can see here a hole is created. We will rotate it so you can see this, a hole is created. Okay, exactly at the location where pin fin is inserted. Okay, so now we will close the design model. Okay, after that we will start the meshing. So we will right click and edit. We have to wait for some time for meshing to open. So the meshing tab opens. We have to wait for the geometry to be attached here. Okay, so the geometry is being attached. Okay, now we can start with the meshing. So first of all, we will go to quality. We will make the smoothing high. Again, element size is 5 centimeter. Sorry, element size is 2.8 centimeter. So we will change it to 0.01. That means 1 centimeter. Okay, and we will see how the mesh is created. So the meshing is in progress. We have to wait for some seconds. Okay, you can see already it's a good quality mesh. Okay, so I think we had to take this mesh, no problem. We can hide this solid body. Okay, hide solid body, and we will see the mesh. Okay, see here, very good mesh. Okay, basically our heat transfer will take place on this surface, and here the meshing is very fine. Okay, again we will make show all bodies, and we will hide pin fin. Okay, and then we will see the mesh. Rotate. Again, see near the contact region there are more number of elements. Okay, so it is a good quality mesh. Okay, so we will proceed this with this mesh. Okay, if you want to see how many elements and how many faces are there, you can go to statics. Okay, so there are almost 1,90,000 elements. Okay, and 37,185 nodes are present, so almost it's a very good quality mesh. Okay, after that we will go to show body. Then uh, again there is a connection. Okay, you can see in contact region there is a connection between this surface, okay, with the fluid. Okay, you can see here there is a connection. What it's used, we are going to see later on. Okay, so we will start defining our boundary conditions. So we will select the face, let this be outlet. Okay, this is our outlet to fluid flow. This is our inlet to fluid flow. Then this surface, this surface, this surface, and okay, uh, sorry, select face, this surface, this surface, this surface, and this surface. Okay, all these together, they are nothing but wall boundary. Okay, after that we will hit the solid. Sorry, we will hide the solid. Then we can select this surface and this surface. Okay, together we can call it as wall fin surface. Okay, so this will be a fin surface. Okay, so after that we can close our mesh. We have defined all the names. We can close our mesh. Next, an important thing is to update the mesh. We had to wait till the green tick appears. Okay, so you can see now the green tick appears. So we will go to Fluent setup and we will edit the setup. We will click on double precision and click OK. So the Fluent tab, it will open. We had to wait for 5 to 10 seconds. So basically our mesh is being attached here. Okay, it will going to recall the meshing module to Fluent module. So it will take hardly 10 to 15 seconds. Okay, so meshing has been set up. So we can set the conditions. Okay, so first is see, in this case it will be a steady state. Okay, steady state, so we are not going to change here. We are not, gravity is not playing the role, so we will not click the gravity. We will first of all apply the energy equation. Okay, because heat transfer is going to take place. Also we will change this flow from viscous laminar flow to K epsilon turbulent flow. Okay, after that we will go to material. So let the material be air and let the fin material be aluminum. So no issue. Then we will go to cell zone condition. So in cell zone condition, our solid is a fluid. Okay, and which fluid is this? This is air. Okay, so no issue, it is a air. You can click OK. And pin fin. Our pin fin is solid. So change it to solid, and it is which metal? Aluminum. So click OK. Okay, after that we will go to boundary conditions. Okay, double click on boundary conditions. Okay, so this is a contact region which we have talked about. Okay, after that our inlet. So let our air is flowing to velocity of, let's say, 0.5 or 0.25 meter per second. Okay, and its inlet temperature is 300 Kelvin. Okay, then outlet is a pressure outlet. Okay, after that we had defined this wall pin fin. Okay, so in wall pin fin we will go to edit. Here what is happening across the wall? Across the wall the convection is taking place. Okay, uh, or you can set the temperature simply. Let the temperature of this wall is 400 Kelvin. Okay, uh, okay, so temperature is 400 Kelvin. Set it to OK. Okay, after that go to mesh interface. We had already discussed in last problem. we had to make a connection between them. Okay, so we had to couple this. So we will select this contact region and we will apply the couple wall. Okay, so set apply, couple wall, apply. Okay, so the entire model is changed now. Now heat transfer will take place between these contact regions. Okay. Okay, after that again we'll go to boundary conditions. So here let's see, this is the wall pin, this is a wall. Okay, so we'll select this and we will give it a temperature, let's say 400 Kelvin, or you can select this convection. Let the convection be 20 watt per meter square Kelvin and pre-steam temperature. Okay, only apply the temperature. Set OK. Okay, this is interface wall, interface wall. Okay, again this is a wall, so we'll set this its temperature also to 400. Okay, select OK. After that we will go to initialize the solution. Okay, so we will set standard initialization. We will select from all zones, initialize. It will take some 1-2 seconds. Okay, after that calculation activities, solution animation. We will set the animation as we had done in previous problems also. We'll go to contour. Okay, deselect all of them. Remember we had modeled the entire modeling we had done from origin. Okay, so we will insert one new plane. That plane will be perpendicular to x direction, so it will be along yz direction. So okay, it is along yz direction, no issue. After that uh, uh, along z direction, its length should be, I think, 30. So first of all, x coordinates are all 0, so make this 0, 0 and 0. So it is along only yz plane, and yz plane make this first coordinates as 0. That means one of the point will be origin. Okay, then second point you can say it is 0 point from y direction, 0 0.3, 0 0.3, along z direction, let it also be 0 0.3, 0 0.3. Create. Okay, after that you can select the temperature. Okay, and select that plane, plane 16, 7 display. Okay, so you can see this along this plane we will see or along the fin length what is the temperature variation that is taking place. Okay, so you can set contour animation, you can say fin length, set OK. Then we'll set another animation. Okay, we will go to contour, again temperature, but in this case we will insert another plane. Okay, and that plane will be now along x direction, so we will change the normal to 0 and 1. It will be normal to z axis. Okay, then here we will give the points. So basically in this case it is passing through xy plane, so z coordinates are 0. Okay, so 0, 0, and you can make this 0, 0 0.3 and 0 0.3. Create. Okay, so untick all of them and select plane 17 display. Okay, so this is along z direction. Okay, after that select this, you can say temperature. Okay, if you want you can also select the animation for velocity. Okay, go to contour, here select velocity, and select plane 7, unselect all, select plane 17, 7 display, select here and change the isometric view. Okay, okay. We forgot to select. Okay, after that, for pressure, if you want, you can also have this pressure. New object, contour, select here pressure, select here unselect all, select plane 17, 7 display. Okay, and change the view to front. Okay, we forgot to change the view of this, so I will go here and we will say this is front and fin length. Okay, for fin length, we will take suppose right fin. After that, we will go to run calculation, and let's say we will have 250 iterations. So we'll start our calculation. So it will take some time for calculation to proceed. Okay, so calculation started. Okay, so I'll pause the video because it will take some time for calculation to complete. Okay, so calculation completed. Now we can see the solution is converged after 82 iterations. Okay, I think we had set some wrong in here, but this animation is okay. So we will see this animation only. Okay, so we will go to solution solution animation playback, and we will see this fin length. Okay, how the temperature variation is taking place along the fin length. Okay, we will slow some speed so you can see how the cooling of the fin is taking place along the length. Okay, this red indicates high temperature zone, and this along the length this temperature is being reduced. Okay, so we'll see all the contours in detail in CFD course. I am closing Ansys. It will take some time to close the Fluent, so we will. Okay, after that we will right click the CFD post and we will edit it. We will wait for window to open. Okay, so CFD post window is open. Okay, so now you can see our model. Now first of all we will insert the planes. Okay, so we will insert plane 1. Let the plane 1 be along XY axis. Okay, and along Z direction we will say suppose it is at 2 centimeter. Okay, so this is our plane 1. After that we will insert another plane. We will say it plane 2. Now what is the location of plane 2? We will say it is along YZ. It is along YZ plane. Okay, then we will insert again third plane. So we will say plane 3, and that plane 3 is along XZ. So it is along XZ and passing through origin. Okay, so these are our 3 planes. We will untick them. 1, 2, 3. After that we will go to contour. We will select the contour. In contour we will select first of all our plane 1. Let this be 100 and we will apply this. Okay, so basically you can see how the pressure variation is taking place. Actually we had made some mistake during making the plane, so animation is not created, but you can see how the pressure variation is taking place here. This is a stagnation point where pressure is very high. Okay, and here boundary layer formation is taking place, separation is taking place, so pressure is low. Okay, similarly you can see the velocity profile. Okay, so you can see this is the formation of boundary layer. This is wake region, blue region. Okay, this is a stagnation point. Okay, after that similarly you can see the temperature profile also. Okay, this is our thermal boundary layer. Okay, So you can try that problem, and by proper plane selection you can actually simulate the problem also. Okay, you can make the animation which that mistake we had made. Okay, so this is our thermal layer boundary. Okay, after that we will go to, we will untick this. Okay, after that, yes, we also want to see this along plane 2. Okay, so we'll apply to plane 2. So you can see how the variation is taking place, temperature variation along the length. Okay, so it is continuously dropping from 400 to somewhere around 360 along the length. Okay, if you want to see along exit plane, okay, so you can also see along exit plane. Okay, this is how the temperature, the cooling of the fin is taking place along the length. Okay, and this is a top view of thermal boundary layer which we had just seen. Okay, again, if you want to see for fin, entire fin surface, so you can select here. Okay, so this is our fin. Okay, so the cooling is being done along the fin length. Okay, so in this way we had seen the temperature contour. After that we will unselect the contour, then we will go to streamline. Okay, along the streamline we will select the surface streamline, and on surface plane 1, and let the number of lines be 100. Okay, apply. Okay, so you can see the streamlines, or make it as 150, more number of lines will be there. Okay, or if you want, you can make it 200, so we'll again have more accuracy. Okay, now if you want to see the video animation, you can see here streamline 1. Okay, so this is how the flow is taking place along the plane 1. Okay, again, if you want it uh, if you want for a 3D, so you can select here 3D streamline. Okay, start from inlet. Okay, apply. So these are the streamlines. Actually they become too much in concentration, so we will make them 100. Okay, in order to improve the visibility. After that you can apply for a video. Okay, so go to animation and then animate. Okay, more proper view we will get in XY plane. Okay, so this is how the fluid particles are flowing, the animation of it. Okay, after that if you want to see how the temperature variation is taking place along the fin length. Okay, so suppose I am unticking the streamlines, I will insert one line, so location line. Okay, now that line will be along y and z, so its x coordinates will be 0. Okay, so x coordinates will be 0. Again, it is passing through origin, so y coordinates are 0, and along z axis I think the length of the fin is 20 centimeters, so 0.2. Okay, so now you can see a line is created. Okay, then we will go to chart. We will go to chart. In this chart we will select the data series, location will be line 1, and okay, in line 1 let the chart count be, sample size be 100. Okay, then we will go to chart, again chart. Okay, chart, we'll go to data series. Here location will be line 1. Our chart count is 100, so we'll get more accurate results. Temperature. Okay, so you can see along the fin length. Okay, on the fin surface the temperature is 400, and that temperature has dropped to 375 Kelvin. Okay, so at the outer tip of the fin the temperature is 375 Kelvin. Okay, so in this way I think we had done the analysis of a pin fin. So in today's session, we had taken two problems. The first problem was related to the counter flow heat exchanger, and second problem was related to the analysis of pin fin. Hope you might have enjoyed the session. Uh, so in this way, we had completed the 1 week student development session for Ansys Fluent Learn from Home. I think you might have gained a lot of knowledge, at least the basic commands how to use the Fluent. Okay, now it is up to you to practice whatever the problem taken in the session, as well as new problems which you faced in your academics in at your home, in order to improve your knowledge of physics and visualization. Okay, so hope you might have enjoyed the session, and thank you for attending the session. Also, if you like the videos, so the session, so you can subscribe my YouTube channel. I used to regularly post videos of Ansys Fluent for different problems, so it might be helpful for you for better learning in future. So like the video and subscribe the channel. Thank you.